Hello everyone. Today I am going to present about a topic CV cyclic voltametry. If you have a data of cyclic voltametry, I will help you to plot in a scientific paper manner using a software called Origin. How to use Origin and how to install it, I will make a separate video on it. But if you used a potentiostat and measured cyclic voltammetry plot for a electrochemical cell, and with that data how to analyze it and how to plot it through Origin, I will explain you. There are many ways to analyze data, but this is very standard and professional way in research and presentation, presenting a plot data of the cyclic voltametry. So I will just start with a small basic, like as you can see here, the cyclic voltametry is like the curve looks like a duck shaped manner. Just stick with present this curve, this kind of curve. You can see it will start with high potential to low potential, meaning here like the x-axis starts with like, usually x-axis starts with low to high ascending order, but in CV, in US convention, it will be in reverse descending order. X-axis will be descending order, and this duck shape curve, the upper peak will be reduction and the lower peak will be oxidation. Just flip this and rotate it, then you will get IUPAC convention. Just you need to just flip and rotate 180-degree, then you can see everything is same. Just if you flip it, high will low will interchange, and you just interchange, then you will get this oxidation top and reduction bottom. So there are these two representations are there. If you started in cyclic voltametry, I will show you in data like which procedure you followed, either this or this. uh, yeah, so we will start with analyzing data. So I have different scanned files of data. So if I open this, this is one data file. You can see the instrument which I used. It's a potentiostat. It's everything is written in this. So the initial potential is 1.2. The highest potential is 1.2 and the lowest will be 0.06. Okay, so initial will be 1.2, meaning it will start from 1.2 and go to minus zero point 0.3, meaning we are following US convention, and the initial will be positive or negative. It is written negative. So this is the scan rate, and which is 0.01, and these are the electrode peak value and current peak value, potential peak value of that point, and this is the um, potential peak point in reverse scan, and this is at the its potential value. Okay, so we will plot this CV by using this data. We can see potential is here and current is here. So you can see, I will show you one typical example of a article. So you can see this is one published article, which they represented a CV curve like this. So the convention is like this, like the current will be, if it is milliamp, we need to label it milli, and if it is with reference, we will be taking one reference electrode. So we have to type title like this: x-axis title and y-axis title, current, and these values. So this is in IUPAC convention. It is ascending order direction. So when we flip, then the oxidation will come here, reduction will come here. You can see here. So oxidation is here and reduction is here. If it is IUPAC convention, if it is US convention, reduction will be up, oxidation and high to low it will start. Yeah. So we analyze the data now. Open Origin. So we will write, so it is like how this is how the interface of origin looks like. I will do separate dedicated video about all the tools and interface of origin. Right now we will analyze the data. So I will first, whatever we do, plots and books, everything, it will be saved in this folder, and you can add multiple folders if you want, and each folder will be like for each project. So I will go to folder 1, and this is my I will name it, it's my CV plot, or I will write a date, 9 3 2025, and I will save this as CV projects somewhere in your location. I will save in desktops. So yeah, so how many folders you can add each folder for, if you are doing regular experiments, you can uh, prepare multiple folders, and each folder you can switch and you can do. So we have one book, I will rename that book. You just need to double click. So every file in origin will have short name and long name. So short name I don't need, I will click long name only. It's better to keep only long name, and the long name I will type as the sample name, sample 1. You can keep sample. So yeah, or else I can keep date, actually 9/3/2020, and here I we can add as many sheets if we want, and I will double click there to rename. I will type sample 1, then click on data, import from file, import wizard. Now it will open, we need to load the data, so that's why we are following this. Click on file, and fetch where is your files. uh, I had kept it downloads and CV data. So I have 4 files. I need to show all 4 in one. So I will upload one by one. Double click over those. It will added here, and click OK. And click import mode. Start new columns, and click next. So untick this auto determine header values. So our data, actual data starting from 0.35. We don't need anything after before it. So we need to remove that, and by using number of subheader lengths, that is 34. So it will be till there, it will be assigned as subheaders, but I need the scan rate value. I need this scan rate value, and it is located at 13. So I will type in long name number 13. So it will be taken as long name, scan rate 0.1, and you can click next. Next, you can unselect this, no needed. Click next, and we need this as X and this as Y. This is potential and this is current. So you can type X and Y, and click apply. So this became X and this became Y. Click next. Next, and it's better to save this filter, so next time you no need to do this again and again. Like we are saving as template, and every time when you plot it again, it will come in 1 second, everything, by using this same copy and paste method. So file description I will type CV import format, and this one itself you can paste, and you can click finish. So now I have 4 data sets, and I need these at labeling at Y. So I will select this whole long name and I will click Ctrl X, and I need here, so click Ctrl V, so it will come on the Y labels, and you can select this for, and you just need to click on one column and hold your right click and just drag. You can get that and click directly here at line. Now you got your CV plot. So you can see the legend. This is called legend. So the legend, it is showing me the which color code, which scan. So first click on any curve, right click and change to 2 to see better. So you can see the green. As a scan rate increasing, the curve is coming up, which is actually the thing. So yeah, but that is top, so I want to keep this legend here in a descending order. So right click there, it will show you some pop up, and click reverse, it will, the order will be reversed. And we need frame to this plot, so anywhere on the graph just right click, you will get again pop up, and again if you want right click, and this is the frame, layer frame. So layer frame has been attached. Now we need to keep somewhere, and it is actually congested, so just decrease the font size, decrease the font size. Here all tools will be there, decrease the font size. So I will keep here, and I want in Times New Roman. Click there and click time and click enter. So it will be saved. And you can see I want to flip this like in US convention. So you can double click there at any number and it will pop up. Yeah. So you can click at scale and click this order, so it will change, and you can click OK. So the order is now changed, and you can again click it, and we need actually this also at Times New Roman. Click Times New Roman, and that have to be 28, size have to be 28, and we need to be bold it, and this is actually what voltage with respect to AG AGCL, and this is actually in volts. So I will type unit volts. Control A, select all them. Again click Times New Roman, enter, and select this size have to be 36, and again this also need to be bolded. And here you can see 1 2 3 4 5 6. So 6 decimals will give micro, so I want this in terms of micro. So you just double click again there, and divide by factor, type 10 to the power of minus 6, click apply, and actually you can drag it. So now it is in micro, and in scale, yeah, that's all. And you can close this dialog. You can again here also 28, and I need Times New Roman, enter. All papers we have to be following this format in presentation or in article submission. This have to be 28, and it have to be Times New Roman. This have to be current, and it's in microamp. So we need micro Greek letter. So here Greek letter is there, click there and type M. So it will, M button is corresponding to mu. So then we need a, so just answer, just escape from there and click A, it will select all, control A. Okay, so this is different font. So first we will remove that and type in Times New Roman and in 36 and have to be bold. Now you place your cursor here and type Greek and type M, and again you unselect, it will come. So this is how it was, and you can keep some gap, you can drag it up. So yeah, this is how a curve, and yeah, that's all. So this is the reduction, and this is the down peak is oxidation. It will come. So this is how we plot a CV, and you can click fit page to layers. At the last you have to click fit page to layers. That is, you just right click, select this, border width have to be, or actually there is a, I think, shortcut is there, control shift E. You can click control shift E, it will like adjust. I need two, so I will click, yeah. So this is how we represent a curve, CV curve, and we will save this as a template. So every time you no need to draw again and again, if for new data. So click file, click as save template as, and user defined in place user defined, you type CV template name. I have four plots in that, four curves, so you can type four curve, and it's in microamp current. So micro current, you can keep it as such. So you can click OK. So it is saved as a template. So you can rename this plot. You can double click, remove the short name, transition to long name, click uh, type as um, plot for curve plot, enter. So it is enter. So let's say now you again have you need to plot single curve. So you just select the two curves, click plot, go to template library, and there all categories you can select CV. I created this, yeah, this one for curve micro. So you can select that one, click plot, and here since we did for the, you can see everything is retained, like the all axes are retained. You just need to click here, right click, legend, reconstruct legend, so it will only show for one. So this is for one scan rate. This is actually that current, and you can change this to color red, and actually you can save this again as template for single plot. Can click save template as, go to CV and type one curve and micro amp, can click OK. So I have, for this is for uh, 0.1 scan rate, 0.1 scan rate, and I have uh, I will plot this now. You can see, click plot, template library, go to CV, select again this one, click plot, you'll get, you got. And if you want to show these two, like in okay, I will rename, I will remove short name, click, I will click long name, and here it is 0.2 scan. And if you want to show this in a one window, okay, now just the presentation of this plot in PPT is like you click, you open PPT first if you want to show, take a new presentation, uh, layout, choose blank. It is better to choose blank. Then I want these two in PPT, so double click there, you got this. Click anywhere here, and click Ctrl J, and here you can click Ctrl V. Yeah, drag it and keep it same. Where is that? Yeah, you can go here, click here somewhere and click Ctrl J and paste it here. So now you have saved, you have now plotted represented in two curves. Yeah, sometimes if you want to directly take these two kind of plots in origin, there is an option for that also. Click graph, merge graph to windows, open dialog. You can actually take, I need only these two, so I will remove this one, and now, and if I click preview, it will show like this. But I want in one row, so click one row, number of columns are 2, so click again preview, it will come like this, and we can click OK. So that is came here. Fine. Merge graph, merged graph. Can click somewhere here, Control J, and go to here, take another slide, Control V. Now you can see both came in similar size, and yeah, it is. So this is how we represent a cyclic voltametry plot and the plotting of it in this origin software. And if you saved the filter, let's say tomorrow you need to do again, you take another book and you need to load data. Same thing, click data, import from file, import wizard, click here and select, let's say this is tomorrow's data, click OK and untick this. Now here there are filtered options, so last we saved this, so click this, you can directly click finish, so the origin will directly take it for you. You just Ctrl X and paste it here, and you can select, you can click plot. Recent plots are already here, so we can click here, so it will come. So this is how it's an easy job. Every time you no need to like do these things again and again, titles. It will make your job easier, and the import also, data importing also. If you saved that filter from import wizard, it is better. So this is how we plot and we analyze the data. And if you want to add anything inside the graph, like any text, you can click right click and it will asks add text, and you can type whatever you want. uh, Control A, this have to be Times New Roman, and 1, and you can paste anywhere you want. Yeah, actually we won't write anything here, we will only write in our in the PPT. So you can take, click here text box, just select text box and click somewhere, right click, that's all, don't drag it anything, just click right click, box will come here and you can type sample 1 and you can paste it here. Take another text box, click here, sample 2, that's all. Yeah, So follow these things, and if you have any doubts, you just please comment me, ask me. I will help you in that. If you're a research student, I these plots are very general in our institute to show these kind of presentation data plots. So I hope you understood the things. If you have any doubt, you can ask me. Thank you for watching.